Fortifications are kind of like the opposite of dilutions. These problems involve adding only the active ingredient to the preparation. For example, if we have a medicinal paste that contains a certain concentration of an active ingredient we'll call brown chemical, then fortification would mean that we would add more brown chemical to the paste. So not inactive ingredients, just the active brown chemical to make it more concentrated. So the result would be that we'd have a greater amount of brown chemical in the paste, so it would have an increased concentration, and would have an increased total quantity of paste. So it adds to the total as well. So a fortification does both. Fortifications can be solved using, again, two equations with two unknowns, or by using the alligation alternate tic-tac-toe. The only difference between the alligation alternate examples we just saw is that this time the bigger concentration is going to be 100%, because that's the concentration of pure drug that's being used to fortify the drug preparation. So in this example, it's a fortification. How many grams of drug should be added to 1,000 grams of 10% to give a 20%? And you can see this is a fortification, unlike a dilution where it would be going down in concentration. We're going to add something and it's going to increase the concentration from 10% to 20%. And we're adding grams of drug, not an inactive base or water or a diluent or something like that. We're adding the active ingredient. And so using the tic-tac-toe method, the desired concentration is 20%. We put that in the middle. The bigger concentration is 100. That's the grams of drug itself. And the smaller concentration is 10%. So we get the parts of 100% by subtracting the smaller concentration from the desired. 20 minus 10 is 10 parts. And we get the parts of 10% by subtracting the desired concentration from the bigger concentration. So 100 minus 20 is 80 parts of 10%. And so then we can set up a proportion to find a quantity. We want to know how many grams of drug, so how many grams of 100%, that will be our x. And we are given a quantity. So we need at least one quantity to be able to find a quantity. This time we're given that we have 1,000 grams of 10%. So 1,000 grams of 10%. We set up a proportion by matching up the quantities with their parts. There's 1,000 grams of 10%. So how many parts of 10% is that? Should be 80. 80 parts of 10%. So there's 1,000 grams to 80 parts. So how many grams are there to 10 parts of 100%? Cross multiply, and we get 125 grams of the 100%. And you can do this algebraically as well. You'd set up your two different equations where you have the 100% is just 1x, and you have the 10%. 10 times, we actually know the quantity there, so 0.1 times 1,000 grams, and then we have that equal to 20% ointment. So our desired is always over here on this other side of the equal sign, and so this is going to be 20% of a quantity we don't know yet. So x plus 0.1 times 1,000 is 100 equals 0.2y. Our other equation over here that we can use to substitute is that x, the grams of pure drug that we add, plus 1,000, which is the grams of 10%, will equal y, grams of 20%. So we can rearrange so that x is y minus 1,000. So let's substitute x here with y minus 1,000. Plus 100 equals 0.2y. We can combine these two numbers to get y minus 900 is 0.2y, and add 900 to both sides. That's what we did there. So y equals 0.2y plus 900 Combine the y terms. Minus 0.2y, so 0.8y equals 900 divided by 0.8. So y, which represents the amount of 20%, is going to be 1,125 grams. 1,125 grams of 20% is what we have. And we can put y up in here to the second equation. And that tells us that x, which represents the amount of 100%, is 1,125 minus 1,000. That's 125 grams of 100%. All right, we're ready to try some alligation alternate questions. First one's where you're just mixing two different concentrations together to get a desired, and the second one is a fortification.